Welcome back to Pre-Algebra with Miss Betsy. Today we are going to introduce the concepts of solving equations that include either squares or square roots. We're going to just barely get a little taste of this, but we're going to see that it's nothing to be particularly afraid of. And you'll learn about it a whole lot more when you move on into Algebra 1. Now, it doesn't matter what text you have for this video to be helpful to you, but the one I'm using looks like this. It's Pre-Algebra for Christian Schools, published by Bob Jones University Press, and I am using the first edition. If you're in that first edition, we are on page 487. We're in section 14.3. So let's go ahead and pray and get started. God, I thank you for a good school year that you've given to us. This past year, I thank you for the opportunity that we've had to learn many new math concepts, things that seemed impossible at the beginning of the year. Father, you brought us along and we've learned how to do them, and I thank you for that. I thank you for your presence with us. I thank you that you love us. And I ask, Lord, that you would be with my students as they get ready for summer, that you would help us to listen to you and to walk in your ways. In the name of Jesus, I pray. Amen. Okay. Before I get started, I have found a new website, and it's filled with math joke one-liners, and I tell you what, they're really, really bad. So either you're glad that this is the last video for this year, or you're sad because I'm getting a whole new collection of some truly bad math jokes, but I know that that's what you look for. Okay, the first one is, can you tell me what state it is in the United States that has the most math teachers in it? Well, that state would be Massachusetts. And then I've got a second one for you, and I thought this one was actually quite good. Can you tell me what you call 3 feet of trash? Well, 3 feet of trash would be a junk yard. So that will be the joke that I'll leave you with this year, that 3 feet of trash is a junkyard. Now I'm on page 487, and I'm just going to go through this material pretty quickly because I want you to get a flavor, get a taste of how to work with these, but this is not something to spend a huge amount of time on if it doesn't grip you right away, if you don't understand exactly what's going on. It says you can solve equations that contain radicals. To solve the square root of x is equal to 5, square both sides of the equation. Now before we do that, remember if we have a very simple equation here that says x plus 2 is equal to 5, of course you know that 3 plus 2 is equal to 5, so x is going to have a value of 3. But how did we solve this using the logic of math? Well, we know that we can keep an equation in balance if you do the same thing to both sides of the equation. And here, when you subtracted a 2 from both sides of the equation, you were able to do what we called isolate x. We isolated the variable, which meant that we found the value for this variable. And that's all we saw. We did that with addition, subtraction, multiplication, division. We're seeing that we can do that with square roots and squares. So if we simply take, this is example 1, we have the square root of x is equal to 5. We learned earlier that taking the square root of a number and squaring a number, that those are inverse operations. Quick reminder here, square root of 25 means look for a number that when you multiply it by itself, let me make this 16. Square root of 16. When you're looking for the square root of 16, you're looking for a number that when you multiply it by itself, you get the number back. So if you take 4 and you multiply it by itself, 4 times 4, you have 16. So the square root of 16 is equal to 4. Now, what can we do to 4? What operation? What's the inverse operation for taking the square root? So that when we perform that operation, we end up with 16 again. Well, yeah, I know 4 times 4 is equal to 16, but if we square it, remember we use this little index here that raised to means that we're going to use 4 as a factor twice. 4 times 4 is 16. So the square root of 16 is 4. 4 squared is 16. So showing us that square roots and squares are inverse operations that undo one another. So we have the square root of x. Our text tells us that what we want to do is simply square both sides of the equation. What have we done here? We've taken the square root. We want to do the inverse operation. The inverse operation of square root is to square. So we're going to square both sides of the equation, which means that we're going to use each of those values as a factor twice, and we're going to see what happens. Next we have, what's this mean? This says to use the square root of x twice as a factor. Square root of x times the square root of x is equal to 25. When you take the square root of something multiplied by its square root, you end up with this x underneath here. X is equal to 25. Now, how do we know just from our definition of square root that this is true? This actually means the square root of x times x. And I don't want to go into right now why this is true, that these are the same. But the square root of x times the square root of x really is the same as taking the square root of this product here. And remember we said that square root is one of a number's two equal factors. We've got two factors here that are the same, so the square root of x times x is equal to x. Alright? That's all that's involved here. Let's go ahead and do another example. We have the square root of what number is equal to 8. We want to square both sides of that equation. Square root of x squared is equal to 8 squared. Square root of x times the square root of x is equal to x. So x is equal to 64. And that's a pretty, what we say intuitive, that's intuitive. Because you know that if you take the square root of 64, that's equal to 8, because what times itself equals 64? 8 times 8 is equal to 64. Well, you can use this same principle here to solve equations that contain square roots. Here we have example 2, and this says, solve the square root of x plus 3 is equal to 8. And this is example 2, and it might look to you a little bit scary right now. Let me see. You know what? My mouth and my teaching today know this is the last video. Let me rewrite this one properly. This is the square root of 3x plus 2 is equal to 8. What do you do when you solve an equation? Well, the first thing you have to do is you isolate the variable. So we're going to isolate the radical here. What that means is that we want to get this square root of 3x all by itself on one side of the equation. How do we do that? We've added 2 here, so we're simply going to subtract 2 from both sides of the equation. Square root of 3x plus 2 minus 2 is equal to 8 minus 2. Square root of 3x is equal to 6. Okay? Does that make sense to you? All we did was subtract a 2 from both sides of the equation. Now we have a radical or a square root here equal to a number. How did we just say you solve equations that look like this? You square both sides of the equation. You end up with 3x is equal to 36. Because when you have a square root and you square it, you end up with this amount here that's underneath the radical sign. This is called the radicand. So when you square a square root, your result is the radicand. How's that for some vocabulary? Now you know how to solve this equation, don't you? You divide both sides of the equation by 3, and you have x is equal to 12. And that's how you solve equations that contain square roots. Okay? What did we do? We isolated the radical right there. Got it all by itself. What did we do next? We squared both sides of the equation. So we square both sides. And then what did we do? We simply solved that equation that results. 3 steps. You isolate the radical, then you square both sides of the equation, and then you have an equation that you're perfectly familiar with and you find very, very easy to solve. So let's go ahead and do one more example that looks like this. We're going to pick a problem from our homework. And we will pick problem number 6. This says, the square root of 4x minus 3 is equal to 5. What do we have to do? Have to isolate that radical. We're going to do that by adding 3 to both sides of the equation. 4x minus 3 plus 3 is equal to 5 plus 3. Square root of 4x is equal to 8. Not 80, the square root of 4x is equal to 8. Of course, that reminds me of the ancient lame joke, why was 6 afraid of 7? Because 7, 8, 9. Okay. Square root of 4x is equal to 8. What do we do next? We square both sides of this equation. As long as you perform the same operation on both sides of the equation, it remains in balance. And you now have 4x is equal to 64, and then you can divide both sides of that equation by 4. You know how to solve these. And you have that x is equal to what? 16. 64 divided by 4 is 16. So x is equal to 16. And 4 times 16 is 64. Square root of 64 is 8. 8 minus 3 is equal to 5. So that's all you do when you're solving these equations. Let me pick another one from our homework that's a little bit different, just to show you what you're going to be doing. And this is going to be problem number 8. This is the square root of 2x minus 1, and that is equal to 5. Okay, do you see that this is slightly different than what we've done before? What we've been working with has been something that looks like this. This is a problem I made up and it's not going to work out evenly. Here, the radical symbol extends over everything. Here it's only the square root of 2x. These two are not the same problem. The radical symbol acts as a grouping symbol. It's like parentheses, so everything there goes underneath it. The -1 is not underneath the radical symbol here. So, having said that, what's our first step that we have to do? We have to isolate the radical. Well, that radical is already isolated. It's all by itself underneath the radical sign. There's nothing added or subtracted to it. So we now are going to square both sides of this equation. 2x minus 1 squared is equal to 5 squared. When you square a square root, you end up with the radicand. You end up with what is underneath that radical sign, which is 2x minus 1. 2x minus 1 is equal to 25. Now you can add 1 to both sides of that equation, and you have 2x is equal to 26. The only thing that, what your new concept is looking here is that you have a square root that you've isolated. You square both sides of the equation. When you do that, what you end up with on the left side of this equation here is the radicand. It's everything that is contained underneath the radical symbol. 2x is equal to 26. X, of course, is going to be equal to 13. Okay? Now let's go ahead and move on to a slightly different type of problem. We said square roots and squares are inverses. So what are we going to do if we have an equation that has a square root? X squared is equal to 15. We want to solve x squared is equal to 15. This is example 3, and it says express the solution in radical form. Okay, what's the inverse of squaring something? The inverse of squaring something means that we are going to take the square root. So the inverse of x squared would be the square root of x squared. We take the square root on the left-hand side of the equation. We have to take the square root on the right-hand side of the equation as well. Now, what's x squared look like? X squared is the same as saying x times x, isn't it? So what we now have is x is equal to plus or minus the square root of 15. Why did I say that x was equal to plus or minus the square root of 15? I said that because remember, when we take the square root of a number, we can have two answers. Because there are two pairs of factors here that will give us 16, aren't there? We can say 4 times 4, or we can say negative 4 times 4. If we want to know two equal factors that equal 100, we can say 10 times 10, or we can say negative 10 times negative 10. Well, when you're taking the square root of something, you have to show that both of these equations, that both the positive square root and the negative square root. So we say x is equal to plus or minus 15, which means, square root of 15, which means that x can be the square root of 15, or it can be the opposite of the square root of 15. And you say, what in the world, what number do I multiply by itself to get 15? There isn't a rational number that when you multiply it by itself you get 15. So this is your answer. This is what you need to get used to using. The answer here is just square root of 15, or the opposite of the square root of 15. If the radicand, the number underneath the radical sign here, is not a perfect square, you just leave it as a square root of 15. You do not use your calculator and say that the square root of 15 is equal to some number, because it's an approximation. Do Do not use your calculator, as you learned in the last section, calculator, to come up with an approximation for the square root of 16. Leave it right like this. That's what it means when your instructions say to express the solutions in radical form. In the math world, this is an exact solution. As soon as you plug that into your calculator and you get an approximation, it's not an exact solution. This is all they're wanting you to do. Let's go ahead and do another problem. This is example 4. If we have x minus 3 squared is equal to 100. The inverse operation for squaring something is to take the square root. So we're going to now take the square root of both sides of this equation. Square root of x minus 3 quantity squared is equal to plus or minus the square root of 100. What do we do when we take the square root of a square? What's that result? That result is one of what we have underneath the radical symbol, okay? So we now have x minus 3 is equal to, but look here, 100 is a perfect square, so 10 times 10 is 100. X minus 3 is equal to plus or minus 10. Now what are we going to do? We want to isolate that variable. We're going to isolate the x by adding a 3 to both sides. So we have x minus 3 is equal to plus or minus 10 x minus 3 plus 3 is equal to plus or minus 10 plus 3. All right with me at this point? All we're doing is isolating the variable. So we now have x is equal to plus or minus 10, not 16, plus or minus 10 plus 3. Look at that for a moment and make sure that that makes sense to you. Well, I check something right quick. What did we say about square roots earlier? We said that there are always going to be two answers. So what two answers do we have here? What does plus or minus 10 plus 3 actually mean? Well, we have two choices here. So x can be equal to a positive 10 plus 3, or what else can it be? It can be a negative 10 plus 3, negative 10 plus 3. So x can be equal to 13, or x can be equal to a negative 7. Plus or minus 10 means we're going to have two answers here. We take a positive 10 plus 3, which gives us a 13. Take a negative 10 plus 3, which gives us a negative 7. So that's the introduction, the end of this introduction to finding square roots of equations and using the process of squaring to solve an equation that contains a radical. Just play around with these, see what you can do. If you get completely confused, send me a text, and I will see you in class on Friday for our final competition.